Welcome to Cloud Training for Enthusiasts. I'm your pilot again, Osato, and then Patrick Aibogun. And today we are going to be talking about Docker and Dockerization. We spent so much time in talking about virtualization, and other stuff, and it was fun. But today we are going to move into Dockerization. So, and it's going to be fun, and we're going to be fast. Understand? So let's go. What is a Docker? A Docker is set as a platform as a service product that uses OS level virtualization to deliver software in packages called containers. The service has both free and premium tiers. The software that holds the container is called a Docker engine. It was first started in 2023 and is developed by Docker. Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your application from infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in same ways you have managed your application. Now, let me bring this thing home. Do we understand this, what we just said so far? Okay, let me bring this thing home. Let's go back to our last lab when we talked about a minute, please. A minute, please. So let's talk about infrastructure. Remember when we were in our infrastructure class, we talked about infrastructure as a service, Docker as a service, infrastructure as a service, platform as a service, and software as a service. You remember, right? Can you remember?
I remembered.
Okay, beautiful. So, and I mentioned that infrastructure as a service, you manage you go to AWS provide you everything that you need, the infrastructure, all the compute instance. So we have to just pick up compute, pick up storage, pick up network, set it up, and use it. Under that status, AWS is only providing the resources for you and ensuring that the physical data center is well managed, right? So in our last class, we've done some infrastructure as a service, like we're able to set up our network, we set up our IAM, then we picked up some storage, we picked up some compute instance, we picked up some network instance of firewalls, and we're able to set up our VM, and we launched the VM, right? And when we launched the VM, we also went ahead to install some application on the VM, or like a WordPress, and we commissioned it, and it was live, and it was fun. So in this, what is a Docker now? When they say Docker is a platform as a service, it means that there's a company that has already set up this networking for you to use, right? They have set up the VM. They just want you to start using it as an application. So then that is the theoretical meaning of Docker. But if I should give you that explanation and I stop there, I'm going to confuse you the more. You understand me? Because that is what the general definition is. But being that I'm from an infrastructure background, I'm going to break it down so that you understand what Docker really means. You understand me? So that when we are working on it, you understand what you are doing, right? So that is the reason why we are going to be talking about Docker. So I wouldn't want to leave Docker for you like this, by defining like this, that Docker is a sort of platform as a service, that product go. At the end of the day, if I leave it like this, you're going to see a Docker like something that is different from what you have been doing before. And if you have that knowledge, if you have that personality that, oh, Docker is here, VM is here, everything is just on its own, you find it difficult to really understand it more. You understand me? So I'm going to come in from the infrastructure angle and explain to us what a Docker really means, what a Docker really is. Are we ready for this fun? I didn't get a response. I know the level. Are we ready for this?
Yeah.
Are we ready for this fun? Ola, I have not heard your voice. If I didn't hear your voice, I will not continue. Ola, are you there? Ola, can you hear me? Are you mute? Ola, can you hear me?
Yes, I heard you.
Beautiful.
Good evening.
Love, are you there? Can you hear me? Love, are you there?
Yes, I'm here. Yes, I'm here.
Okay, beautiful. So now let's break it down. Let's dismantle Docker so that we all will understand what Docker really is. So I'm going to set up a new, as our custom is, build up a new infrastructure. Now, please be attentive, because if you don't get it here, it will be difficult for you to catch up later. Okay, now this is it. Normally, we have, as I mentioned before, when I was explaining Docker VM, that a server, a physical server is called a bare metal, right? You remember, right? A physical server is called a bare metal, right? Let's assume all these things. This is a server. This is a server. So in data center, regular, let me not call it data center, in a storage house where they put equipment, right? In an IT warehouse or in an IT infrastructure, there is a place, there are servers, there are network, there are powers, cooling, and everything, right? So when a company decides to take over the server management, the physical server management, the physical network management, the whole environment, you understand me? You call and they just provide you those resources for you to use based on you as you pay for it. You know, based on the time you are using it, and you pay for those time. We call that kind of service as cloud service. I mean, public cloud service. Now we say we have three types of cloud service. We have the private, we have the public, we have the hybrid. Now we have explained that. Then I also may explain that in that same cloud services, that means they have servers, they have equipment, they are renting it for you, that there are some things that they will provide for you, right? For example, they provide the first layer, which is networking, the physical networking, they provide it for you. Then another aspect, which is the compute instance, you understand? The compute instance, they provide it for you. Then another aspect, the security, they provide it for you. The network, compute instance, and storage, they provide it for you. You understand? Then there's another aspect, the OS and application, they provide it for you, right? And I'll be naming it, don't worry, as we are moving on. We already have it here. I think we already have, let me just refer to what we have before. That'll become easy. We've already done it so that we'll not be clouding ourselves more and more. So what Docker is just like an application. It's nothing like different from what we have been doing. It's the same. Remember, we just mentioned this. Now, for example, you want to set up a system, you have to get a RAM. For example, you want to buy a system, you have to get a RAM, CPU, network, operating system, the ports, you understand? These are the things you need to get a system running. Let's use our basic laptop that we are using. Your laptop, for your laptop to run, your laptop needs the hardware, which is the compute instance, the RAM, the VGU, the visual display unit, the port, the network, which is we are using to communicate now. So when you go to an infrastructure and you decide to rent all these things and be using it, that infrastructure is providing to you a software as a service, infrastructure as a service. Now, why do we now need a Docker? Now let's go a little longer, a little deep, just a little deeper. Let's assume now we have already set up our network, right? Our VPC and co, which we all of us can do now. Then we have put on our storage, maybe our block storage, right? Block storage, which, for example, now we use a general purpose disk, GPD or GPDS. Then we have set up our compute instance. Maybe we have used EC2, right? EC2 instance resources. Remember in this compute instance, we are using a VM here, right? In our last lab. We're using a VM here, right? Now we have put on our operating system, OS. Last time we used Linux. Now, which of the Linux did we use? It was Ubuntu, right? Huh?
Yes, Ubuntu.
Ubuntu.
We use Ubuntu. Okay, now when we got to this part, we started putting our application on it, right? Our application like the Nginx, Nginx, we put WordPress, WP. We also put an application called DB, MariaDB. We install MariaDB. We also install PHP, right? All these things are application. Then after we install the application, what the next thing we start doing, right? We now use the public IP address through the network. Through this network, we're able to access it from the public. You understand? Okay, now let's come back to these three parts. Let's come back to these three parts. Remember, I told you that for this three parts, which is the computing standard, a VM is actually a server, a physical server. I said a VM is a physical server, right? A physical server. The reason why I always do this illustration is that it will stick. There's no how. Since we are doing this class together, we are building our lab together, it will always stick. You will never forget. You will never forget it. This is the practical aspect. Now, we said this is a server. Normal, just consider server like normal compute instance. It's a server in the data center. In this server, what they do, they put an application called, okay, remember the name of the name of the system software that they put to virtualize it.
Hypervisors.
Beautiful. Yes, it shows that hypervisor. Now I said we have two types of hypervisor, hypervisor 1 and 2. You understand me? But in this case, because it's a bare metal, this server is also known as bare metal. It's called bare metal because they just call it bare, like normal bare metal, you know, like regular metal. That's the meaning of server. It's also known as bare metal. So when you put, excuse me, when you put an hypervisor on this bare metal, you can now divide the server into different compute instances, also known as VM. Please stay with me on this. Without this hypervisor, you only use this server as a unit. But because you have put an hypervisor in this server, you cannot virtualize the server. Now that you have virtualized the server, meaning you can divide the server into different units, and the server will be acting as if each unit will be acting as if they are separate server. That's what it means by virtualization. Okay, this is a VM. Let's just put VM. Let me increase the font. The font to, let's put it to 12. This is a VM. Okay, now a VM means virtual machine. That's the meaning of virtual machine, meaning that it's a machine that is running as if it's a real standalone machine, but it's not really a physical machine. But it's a part of a physical machine. But that machine can run as if on its own. You understand me? You can configure it on its own. You just like consider it like partitioning, but it's not really like partitioning, because partitioning is about dividing your hard drive, right, into different units so that you can share the hard drive. But when you're talking about virtualization, you are dividing the whole resources of the system, meaning you divide both the storage, everything, both the compute instance, you are sharing it. For example, if this server is, we have explained this, but I'm just trying to have a recap so that we will remember. If the server, this complete server is actually, let me extend it like this so that we can, please just take note that I'm talking about this server. If the server is actually like, maybe we have 3 gigahertz hard drive, 3 gigahertz processor speed, and maybe 500 gig hard drive and GB hard drive. There may be 8 gig RAM. 8 gig RAM. So when you virtualize it, it means that as you are creating a VM from this, they're going to be taken from these resources, these general resources that this server has. For example, if this VM that we just created, now maybe we can just collect like 1 gigahertz processor speed. Maybe we'll collect 20 gig memory, you understand? Hard drive, or you can call it memory. They will collect out of it, maybe out of the 8 gig RAM, we'll collect like a 2 gig RAM, which is random access memory. So what does that mean? How many will be remaining? We will now have like, we will still have this space remaining here will now be like 6 gig RAM. We still have like 480 hard drive, and we still have 2 gigahertz processor speed. But when you are using this VM, it will look as if you are using a server. Because why? You have an hypervisor installed in this server. So now, that means, remember when we were launching that instance in our last lab, you were selecting from it, right? Some of us launched, we used EC2 micro, right? Which was having like 0.5 gig processor speed, 1 gig RAM, maybe. And when we were collecting our hard drive, we collected 8 gig hard drive. You remember, right? That was what we used. So now, as those resources, those instances we are creating, as I mentioned before, we are actually collecting it from a physical server. But those were the things that you were picking. Now, what does that mean in a virtual machine? Meaning that let's assume Michael was the one that used this. If Love wants to use this, Love will still come to this server and cut from it. Then it will take another space. Maybe another, if Love have picked out of this, let's say that Akin come here and pick from this. You understand me? So the remaining, so that's how you're going to consume it until you finish the whole resources. You understand me? Until you finish the whole resources. But when Akin log into this server, Akin will be using this server as if he's using a whole complete server, because the network will be different, everything will be different. So that part that Akin is is using, or that part that everybody is using, is called a virtual aspect, an instance of the whole server. An instance. This become an instance, this become an instance of this server. That's why you hear instance, launch an instance, create an instance. You understand? Means you are picking from a server. Now, what is now a Docker? Normally, you know, remember when you finish installing, when you finish creating an instance, all of a sudden you started installing an application, sudo apt install, sudo apt this, sudo apt that. You understand? So sudo app this, sudo app that, sudo app create. So automatically you are using the whole VM. Now look at the advantage of a VM over server. So instead of assuming if it was before the hypervisor became very relevant, meaning how many server, like say 1, 2, 3. So meaning if Aki want to use an application, a server, it would have run and go and buy a complete server and put an application in it. That we allow we buy a complete server. Now, because of this type of hypervisor, Akin will no need to buy a complete server anymore, but they can just be sharing one server in an hypervised way. Now, this is a VM. Now, what a Docker is like, it's also an application. It's a software, it's a system software. That when you put it on any VM or a server, you can let me not come like that. It will still be confusing. Sorry. I'm trying my best to break it down so that all of us can catch up. I don't want questions to come in, something that would have been easy. Now, when you want to load, for example, we were running an Nginx. For an Nginx to work in this VM, that Nginx will come with all the dependency, all the application it needs to run in this operating system. Because when you put a VM, you have to put an OS on top of the VM. Just like when you have a system, a laptop, you must put an OS. You must put an operating system so that that application will be able to use that VM. Maybe some of us will use this Windows. Some of us use Mac. Some of us use Linux. So that OS is what you need to put on top of that VM or any server or any laptop. So from that OS, you can start putting your application. But the disadvantage of loading an application on top of OS is that when you want to load any application, let me bring this OS, let me bring it this way so that it becomes easy for us. Please take note of what I'm trying to do. I can make it so fast than this, but I want everybody that even if you don't have any IT knowledge, you should be able to understand what we are talking about. Now, if you have OS, I'm talking about this OS now. I'm dealing with this OS, this operating system that we are familiar with, like the Windows or when you put a window in, let's assume this is a Windows OS. Have you not noticed that sometimes when you want to install an application in your Windows, it takes space, right? For example, Microsoft Office. Microsoft Office is almost like it's almost 500 megabytes. And then if you are installing CorelDRAW, for example, now this I put an OS here, maybe I put Windows here, and I want to put an application on top. So if I'm putting an application on top, I will need to put an application that is compatible to this OS, right? The application must be Windows-based application. So, and this application, for example, I'm putting MS Word, Office, I'm putting Office. So for the Office to work with this operating system, this Office will come with all the resources needed to communicate with this OS and all the resources needed to communicate with this VM, with this server. This is the server now. Then it will also come with all the resources needed to communicate with other applications. Because it's not only Windows that will be there, some other applications will be there, some dependencies will be there, some drivers will be there. So for this Office to function very well, you come with one, we call it, it will come with the application itself, which is the Office itself. It will come with the Windows patches. They will come with other dependencies. We come with another dependencies. Let's say we come with Office, which is the application. We come with the Windows patch. We come with, let's add this Office is application. We come with Windows patch. We come with other drivers, other OEMs and drivers that will make sure that this Office works. So if Office is coming, assuming all these applications, but let's assume that this Windows application, this Office application is supposed to be like, let's say, on 50 megabytes. That is normally, that's how Office is supposed to be. An Office is supposed to be like maybe 500. It's not, sometimes it's not even up to 550 MB. So because it needs these Windows patches for it to work, this Windows patches may be like 300 MB. The drivers, the dependents and payloaders, maybe will come with like another 200 or maybe 250 MB. Or let's just wrap everything up. Say, since to make it, maybe it will now come with like 150. So altogether, for Windows to run in this operating system, in this Windows operating system, the Windows Office will now be total of how many? 500 MB. So that's why you do take time when you are, and some application that is not needed, some features that is not needed, they will be loading it. So you wait, that's why whenever you are installing an application in your OS, it takes time because all this, you want to put it on the DVD, either you get it on the DVD or you download it, right? When you download it, you will not put it inside this VM. Okay, let's assume now, this is already 500 MB. I will say this hard drive is 20 gig. You remember, we already used that many out of it. I've already used up to like, because by the time the thing even enters, sometimes it can expand because it can, sometimes some application can start duplicating. And at the end of the day, maybe before it finishes installing, to take like 1 gig or 500 or 700 gig. So that means Windows is coming with, let's assume Windows come with 500 gig, and after installation, it ends up with 700 gig. And you want to put CorelDRAW. CorelDRAW again will still come with CorelDRAW. Let me duplicate this. But I want you to understand the reason why people are talking about Docker. Why people are talking about, why are we using Docker? If CorelDRAW is coming, maybe I'm using simple application that we are familiar with. I know most of us have heard of CorelDRAW, right? Yes, some of us have heard of. If you've not heard of CorelDRAW, CorelDRAW is a graphics application that you use to do some. It's a graphics application you use to design, or Photoshop. Some of us have heard of Photoshop. Photoshop, because it's a graphics application, it can come up to like 200, or maybe Photoshop itself would be like 300 MB. So if it's 300 MB, by the time it uploads, maybe at the end of the day, you're going to install CorelDRAW in your system. It's going to take like OS is taking, Office is taking, how many? 500 MB. Office take 500. Because Office will come with all these things. CorelDRAW will also come with all the dependencies. Then Office will also, let's say CorelDRAW now is taking how many? If you calculate all these things together, 300 plus 300 plus 150.
750.
750. But let's say CorelDRAW comes with its own. C, let me use CorelDRAW as C, draw. Come with, let's say 750. GB, MB, right? That is not yet, it has not start running, no. It's just for it to install. Okay, assuming you want to bring another application now, maybe just mentioning the application. And at the end of the day, you see that all the application you are bringing, they will be coming with their Windows patches, their drivers, and other dependencies. You understand? Dependencies, all of them will be coming with their own dependencies They'll come with their windows, the drivers, dependencies, their windows, their driver dependencies. So at the end of the day, you realize that the hard drive will be. I'm just trying to explain it so that it becomes easy. So now, this one comes with 750. This one comes with 500. Maybe on the application. At the end of the day, if you realize that this one will only take application, 20 application. I'm not saying that the application is running now. You're not started using the application to save files. You understand? You've not started using it to save files. You're just installing the application to use. You will notice that this, by the end of the day, it will take like, let's say 30 applications. 30 application to fill up this. It will take like 30, let's say 30 applications. It's not even up to 37. Let's assume everything is 500, everything is 700, and when they are running, everything runs at 1 gig. So you're going to have like 20 applications here, right? 20 app. Mind you, the processor that we have, remember we just have a processor of 1 gig, 1 gigahertz processor speed. When these applications are running, because the patches they are going to be consuming processor speed. So at the end of the day, your system will be very slow because while you have more application, one processor that is processing the application, processing different patches of the application, processing different drivers of the application. You understand me? Processing different dependencies of the application. So at the end of the day, your 1 gig RAM, your 1 gig hard drive will be slow. Then your RAM, depending on the application that you load, if you load this, some applications, immediately just on your system, everything will load to your RAM. So your 2 gig RAM that you have here will be overwhelmed. Your system will be very slow. So one, because why? The application is running. All the applications they are running with their Windows patches, with their dependencies, and at the end of the day, you have overcrowded your VM or your instance. So this is what Docker is here to. Docker is addressing. So Docker says, instead of bringing all these patches, all the applications coming with their patches, why not, after installing the operating system, let me put it here so that, let me shrink this. Or should I go to a new page? I want it to be in this same page. Please, if you don't understand, answer questions, please, because this part is very critical. I want us to catch it. Now, what is Docker addressing? In lean management, lean says we should try and reduce waste. That's why lean is part of agile processes, which means try and reduce all waste, anything called waste. So as a DevOps engineer, you're also going to be helping the company to save cost. Now, what is Docker doing? Docker says, instead of bringing all these applications and their patches, what you just do, you just run, let me bring it here. Sorry, let me try and reduce this to this. Okay, now this is what Docker is coming to do. Docker says, instead of bringing all the applications to come with their patches, their dependency and everything, why not install an application that has all these patches as an engine? The application we have the operating system patches, the operating system drivers, the operating system dependency as a unit. Sorry, let me go back. As a unit. So all these things will be like as a unit. So that after installing this system as a unit, then you can now start putting different applications on top. Oh, sorry, I will need to go to a new page. I'm trying my best to manage it, but I don't want you to confuse anybody. I want us to be clear with it. So what is Docker addressing? Docker says, instead of bringing all those applications, let me bring one of this one up. Let me bring this one down. Okay. Let me return this. Oh, shit. Sorry. Oh, okay. Control D. Control C, X, Control D. So this is a regular ROPM. We call it ROPM. You understand me? Meaning you have to install the patches, install this, install that. It's a regular ROPM. Now, what a Docker is addressing, Docker says, why not all these, leave the application, keep the application separate. Why not run an engine that has the drivers? Now we have the drivers, it will have the dependency, and these ones, they will be running as if they'll be running on their own. It will be running just like an application. So that the next thing you just need to do is to be putting all the application that you want to run on top. So for example, now, if you want to run a Corel Draw, we will just put, if you want to put the Corel Draw, we just put the Corel Draw on top. Then this, let's say Corel Draw, CG, the Corel Draw, right? Now, if you want to run window, what do you put? What do you call that application again? Microsoft Office. You just be putting all the application on top. Then, if you want to run what again? Let's assume you want to run. Just mention any application, please.
Excel.
Excel is under Excel. Okay. You can put Excel, let's say, let me see my application. So what do I have? Let's say WhatsApp, Photoshop, let's say Photoshop, PSD. So what does this mean? It means that because this engine is running all these dependency, so instead of us bringing all applications will be coming with the Windows patches and everything, you can see now it will save this 300 MB, to save how many space, to save all this space. And if Corel Draw in terms of Docker, it's not all the features that is actually put there. It's always small. So at the end of the day, Corel Draw will just come like 15 MB to run. Office will come like, let's say 50 MB. Then Photoshop will come like, because Photoshop is a graphic application, we can put it 80 MB. So you can see, and at the end of the day, you see, I mean, you know, with this case, you can see that we can run so many applications in that hard drive that was 20 gig. So this one is 300 megabyte, this is 150 megabyte, this is 500 megabyte, this is about 750. So at the end of the day, all you just need to be doing is to be putting all the application on top of this engine. So this engine now is called the Docker engine. Let me push it down. Let me separate it. So this engine is now called the Docker engine. You understand what I'm trying to say? Do you understand the concept of Docker now? So this is now called a Docker engine. Let me make it big. So this Docker engine, the work of a Docker engine is to zip all this dependency as a machine, then also provide the environment for all these applications to run. But just that the way it's running, they're going to be running as if they are independent application. It's going to be zipping them together as a container. Sorry. You know, we know you hear about container, you know, consider container as, sorry. I'm having some allergy, so it's just affecting me gradually. But I believe it's the weather. So the work of a Docker engine is that it enables all these dependencies to be running in the engine. So all you just need to be doing, any application you want to run, you just zip only the application in. Maybe the application must be the operating system of this VM. So if we are running this application, this particular application on a Windows machine, meaning the Docker, if the Docker must be Windows Docker and the application must be Windows-based Docker. You understand? So we cannot be running an OS, then we want to put up a VM, we want to put a Docker engine, we'll be putting Linux, it will not work. So if you are running a Docker engine, you must put a Docker application on it. So that is why you see some design like this. So many companies will design. I mean, most of us have seen something like this, right? Some even put it this way. So it's the same thing. So what does this mean? It means that this is the engine that is carrying both the dependency, the patches, and everything. All these ones are just the application that you want to be zipping in a way so that it can become so compatible, so easy, and save cost, and not consume resources. So this is what I did. It's the same thing. This is my own way of. It's a virtual machine, a Docker. No, a virtual machine is not a Docker. A virtual machine is a VM, is a bare metal. It's a server that is hypervised. So even after hypervising your VM, a portion of that part of that server that you picked is called a virtual machine. This is a virtual of this machine. And it's going to be acting as if it works on it, so, but it's not really a physical machine. It's a virtual machine. This is a virtual machine, right? But a Docker is an application. So what does that mean? After putting a virtual machine, you have to, after putting on your operating system, you have to put another application here called a Docker engine. So you install Docker just the way you install another application. You understand me? The way you install other applications, that's how you also install a Docker machine. But you must install it on top of an OS, an operating system. You understand? So that is a virtual machine is just like a server, a part of a server running as if running on its own. That is a virtual machine. But a Docker is an application that enables you to run so many applications because why? It comes with its own patches, as I explained here. So this is now your Docker engine. So because it carries all the dependencies that application needs to run. So all you just need to be doing, instead of installing different applications separately, you are using a Docker to be managing the application. You understand me? So those applications will not be coming with their dependency in patches. They will just come with only the minimal resources needed for the application to run. Because why? All the dependency needed has already been provided by the Docker engine. Do you understand? Do you understand now? Hello?
Yes,
Yeah.
Hello, do you understand now? So, well, if they ask you what's the difference between a Docker and when they say what's the difference between a Docker and a VM, A Docker is an application that helps you to manage application. So a Docker is a system application, it's a system software that help you to manage application. So Docker is more of application based. So it's focused on making sure that you have many applications running with the minimal resources. That what I mean by resources with your storage. So when somebody is asking me what's a different type of Docker, I don't understand. There are no different type of Docker. We only have Docker we only have different Docker. Just the way we have different operating system. So we have Linux, we have Linux Docker. I mentioned, maybe I told you that for a Docker to run, you must have an operating system. So this operating system, the name of this operating system will determine the kind of Docker engine you are going to run, right? We have the Linux, we have a Linux, we have the Ubuntu, the Windows, we have the other different variants. We have to say all of them. So now, let's put it this way. A container. Now, why are they calling it a container? I've explained to you why are they calling it a container, because what? It's a Docker engine. It zip different application. It zip application in a way that it zip it in a format that this application will be running inside the space allocated for it. This application will be running inside the space allocated for it. This application will be running inside that space allocated for it, because why? They are all using this engine. So because it zip an application to be running in a place that is allocated, that's why it's called a container. So that part that application is running, that allocated resources that this Docker engine provides for this application to be running is called a container. You understand? So that part of that version of the application that is running inside container is called an image. So this is a container having the image of what? CorelDRAW. This is a container having the image of what? Microsoft Word. That means a container having the image of what? Photoshop, also known as PSD. You understand me? PSD. So this is an image. So that part of, so in a regular laptop, maybe your system, if you want to install an application, you use an ROPM because it comes with all the installation files, right? So this is called installation files. But in Docker, it's not called installation file, it's called an image of an application. So this image, if you run a Docker of a WordPress and you run an application of and you run a installation file of a WordPress, at the end of when you share the URL, they'll be the same thing. You understand? Because there's something different. It's just that you will not even know that you are ever running an ROPM or a Docker. You understand me? Because they look alike. The outcome they look alike. Now, this Zoom we are using is a Docker. It's already zipped inside a Docker. The Zoom we are using to communicate now is a Dockerized application. WhatsApp, because they know that the company that provides WhatsApp service know that if it's to put WhatsApp in an application, imagine you know how many people that are using WhatsApp in this world. There are so many now, you understand? If they are to run it as an application, it will crash. So what happened is that they will run WhatsApp, maybe like you can run 5 WhatsApp applications. Just like the way you can run 5 Photoshop applications. So you can run 5 WhatsApp applications in one Docker engine. You can run 20 CorelDRAW application in one Docker. You understand me? You can run 20 Microsoft Office in one Docker, because why? What you are running is not the complete application. You're just running the image, only the file. So you can put like 20. Imagine, but just like in a regular VM, you can only install one application. You know, you can only install one CorelDRAW. So when that CorelDRAW refuses to boot, or come up, it crashes. You have to install on that one. But in Docker way, you can install 5, you can install 5, you can have 5 images of Microsoft Word. So that makes it more relaxed and more resilient and more resilient, more relaxed, makes it more available. Because when one of them crashes, you can use the other one that is available. You understand me? So this is the work of a Docker. This is the function of a Docker. Because it provides the engine, which you are going to install now. Then you start zipping your application. And interestingly, the way they will operate, they will be operating as you can also allocate different network to it, different ports to it. You understand? Different form. You just be using it as if you are going to see how we're going to be zipping and unzipping. But I just want us to understand the concept of Dockerization. Any question? So I love your question. The meaning of Docker, when you understand the Docker, you understand the difference between a Docker and a virtual machine. Because some recruiter will just look at their profile like, so that is why he's saying he's a DevOps engineer. Let me even ask him simple question. Simple question like, what's the difference between a VM and a Docker? You will not say, they will just know automatically if you don't understand this concept that I explained. You understand? They will know. So they will know that you don't understand it. But this is where the work of a DevOps engineer actually starts from. Because the development of that application using the, the development using the Git and GitHub and zipping it, most times it's not your concern how they design the application. But your work is to convert the application that is mostly ROPM to a Docker file, and push that Docker file into your engine. Either you're using a VM or you're using a Kubernetes engine. Now, I'm going to explain to you what is a Kubernetes, because Kubernetes actually is an extension of Docker. It's like a manager. It's an application that manages Docker. So that's what the Kubernetes engine is. I think I should just explain what the Kubernetes engine is, so that by the time we finish Docker, we can quickly just enter Kubernetes. Now, what is the Kubernetes? The Kubernetes, you see, remember I mentioned that immediately this engine is running in your, let me make the engine very big now. Please, a minute. Kubernetes engine. I mentioned now that this Docker engine carries both the patches, the drivers, and everything it takes for the application to run, while you just zip up your image inside and run your image as a container. Now, what I said, you can run 5 Photoshop container. Let me make it small so that it can be interesting. Oh, okay, good. Delete this. Delete this. We can run 5 Photoshop. They'll be running separately. You can run 5, assuming, okay, let's use only Photoshop as an example, for instance. For this Docker image container that is running, that is running this Photoshop image, for this one to communicate to this, they have to be communicating using the port, just like the way we also did the VM. You remember we say we have to expose some port 80, port 22. For example, if this is port 40, this is port 40, meaning this port 40 must be open for them to communicate. This port 40 must be open to all of them to communicate. But the challenge is that when this one dies, sometimes these two will be running. You need to run another application that will be able to provide this. You can decide to run these 2 applications, then throw a load balancer. A load balancer is another application that enable just like a network that makes two applications to communicate. I shared it last time. Maybe throw a load balancer to these two. Maybe throw a load balancer to these two. So what does that mean? It means that if this is a load balance, this two application is running. So it's going to have just one access point. So maybe the access point will just be here. Many people will be using this application from here. Meaning if this one goes off, as far as this one is still here, the application will be up. So you can decide to have like 20 applications here. You can put like another application on it. All you just need to do is just to extend the load balancer and connect it. Make sure that the load balancer is speaking the same application.
Patrick,
I can hear you.
is it the work of the DevOps engineer to install this load balancer?
It works, your work. Infrastructure engineer, you have to be in charge of creating.
Okay, can we see? I know we did it the last time. I'm asking that we see,
Yeah, I'm going to do one.
Anyway.
Load balancer. You want us to practice load
Okay.
balancer, right? We'll practice a load balancer.
Yeah, I saw one of your videos. You did it.
Yes, I'll share the video again to you. It's a simple walkthrough load balancer. You can even do it yourself. Understand? It's provided, it's also part of the services provided by AWS. We have three types of load balancer. We have application load balancer, network load balancer, and classic load balancer. I think if time permits us, I'm going to explain more, but I've done a video that you can just watch, the simplest, seamless stuff, and you can even use it to practice your VM. But it's very, very important you know that load balancer. Normally, I'm supposed to be taking load balancer now, but if I should take load balancer now, which is something that you can pick up, this Docker is more important. Because there's no how we are still going to be practicing load balancer as we are going. You understand me? So just stay put, but I'm just giving you that so that you understand a deep knowledge of what a really load balancer is. Load balancer is just a single application that enable you to connect other applications to it. You understand me? While you receive, you have one endpoint. For example, this is where the people are coming to use. These are the people using it. So you can pull like 4 applications on it or 4 VM. So it's like in case one of the VM goes off, are you getting me? The load balancer will still be servicing. These two will still be available for people to use until all the loads inside the load balancer is off. Then your application will be offline. So a load balancer is a way of providing high availability. So this is what a Docker is. The Docker will provide a load balancer. You can decide to design a load balancer that will be servicing. For example, this is a Photoshop. Ola is using Photoshop. Doing is using Photoshop. Everybody is using Photoshop. Now that Photoshop, it has 3 containers. That we are running 3 containers of that Photoshop because of this Docker. So what happens is that when this one goes up, this one goes up, this one goes up. Now the help of a Kubernetes engine. The Kubernetes engine is helping you to manage all these containers, so that in case anyone goes up, it will repair it, it will fix it back. You understand me? How people use this container, how people access the container, that is work of a Kubernetes engine. It's also an application. That's why you see it like this. It's like a controller. Docker is a ship. It's a shipper. It's like a transportation system. Why this is like the driver, the wheel that manage how this Docker works, how they function. This application function, all these things are, what they are after is to provide high availability. So I will explain more about Kubernetes when we get it, but that is what a Kubernetes actually is. The main challenge, that's why we have to spend time in learning about this VM this VM, because this is where the main thing is. Because if you understand VM, you can understand Docker, because Docker is just like an application. It's just like an application. Just that the work of a Docker is that instead of you installing all the application with all their unnecessary patches per application, you can just install one engine that have all these patches. Then you can start putting all your application on top. And this application can be using your application as you like. You can start to tie the application together. You can start to keep one application to be running independently. You understand? You can decide to manage the application. So when you are managing this application, different application, you have another application again that manages, that help you to manage all these applications that runs your Docker. That particular application that help you to manage applications. Sorry, I don't know how to put the language to use. So these are applications. This is your Docker engine. So there's an application that will help you to be making sure that these services that are running where they are not clashing with themselves, that whenever one goes off, another one comes in, it's called an orchestration tool. You understand me? Kubernetes is not the only orchestration tool, just that Kubernetes is popularly used. We have what we call Docker Swarm. There are so many orchestration tools. So that when Dockers are running, it helps you to manage the Docker. So Kubernetes work is to manage this application that is running, this container that is running. That is what a Kubernetes does. Why a Kubernetes?
Patrick,
I can hear you.
Patrick, please, I'm getting confused. Let me try and break it down to what I think you are trying to say to see if I'm getting along.
Okay, please.
Let me put it this way. Can I say like a Docker now is like an extension bus that has many socket points where all of us can plug our, okay, let's say for a laptop, for example, I can be using point A, and someone is using some point B, point C, point D. Then let's assume that all of us are working together at the same time with that particular extension bus. Then one person's own goes off or gets back. Are you now okay? Are you now saying it is the Kubernetes engine? We now like try and repair that person's own while the rest of us are still working, ours are not affected. Is that?
Yes.
Okay.
Some that illustration is still okay. Just consider like, okay, instead of I have one extension bus, that extension bus, everybody wants to come and charge phone. You will come with your charger, you plug your charger. This one will come with the charger, will plug his charger. So a Docker is just like a charging port. You say, okay, don't come with your charging head, just come with only the cable. You understand me? The cable is just the application. Instead of coming with your charger here so that you will not make that extension look so cumbersome, I can just plug one of my application, maybe my charger. I'll say just come with only your cable. So all you just do, you just plug your stuff to the cable, your application will be running. So this is like, that's another illustration. But a Kubernetes engine will make sure that what you have defined in that engine, if I say I want 5 Photoshop to be running, the Kubernetes engine will make sure that it's 5 applications that will always run.
Okay.
So, but those applications, they are independent, right? You can use a load balancer to manage it. But when one dies, you have to go there manually and bring it up.
That's again.
But Kubernetes himself, we look at as before it dies, it will alert you. As it's dying, it's creating another one. So in that way, you can see that your application will be highly available. When it repairs, it does so many things. So I'm going to be talking about that. But understand the basic things. This is the main work, which is Docker and VM. If you understand VM, you can learn every other thing. But I want us to focus on this Docker. So I know I've explained Docker to you in the lowest level that you can understand. I don't know. Is there anyone here that have not understood what I've just explained? Please speak now. We are going to go into practice. I don't think time will permit us to take practice now, but I want us to understand it clearly. Speak now.
Hello, sir.
I can hear you.
Does it mean that all operating system has its own Docker?
Yes, all operating systems have the Docker engine that runs with it.
Okay.
And so whenever you are even designing whenever you are even running your application, you are even running your stuff, you cannot use Windows Docker file, Docker image on Linux. It will not work. For example, now I'm using a MacBook. I have a Docker application. Let me share my own Docker. You guys will have to go and install Docker. It's it's an important thing. Mind you, Docker is the name of Docker is actually the company that is providing it as a service for us. You understand what I'm saying? What I mean? So what does that imply? It implies that if you want to learn Docker more, you go to their site. It's an open source, meaning that it's for everybody to use. It's free. Docker is free. It's an open source. This is Docker. You can see this is a Docker engine. See, just like the way I have other applications in my system, right? I have Docker. Now this is not a Docker. This is normal Photoshop installation. So you can have Docker installed and still have other applications installed. I have a normal. This is Slack. This is a normal Slack application. This is a normal. But this Docker now, if I open my Docker now, you see application is inside. So how do I know if I have a Docker? You use terminal to understand. You can also use your GUI to know. So see, as I'm saying now, what is happening now is loading my Docker engine. My Docker engine is fully loaded now. These are the image. It's loading my Docker desktop. So what is happening now is, excuse me. What is happening right now? What you just witnessed now is, I just started this engine now. You understand me? This is the engine that I just start now. So it's going to. This is a MacBook. I'm using MacBook. So which means it's MacBook. It's Mac OS Docker that I'm running. So now, if I want to run any of my Docker file, I will just, these are the images that is running right now. These are two images that is running. So I can decide to put Nginx. Right now, they are not running. This is just an application that I just put. So if I want to run, I'll just click run. So automatically it's open. I can start to run, look out for any image and zip it in and use it the way I like. I have explained an instance is a portion of a VM. An instance, just consider it as orange. The complete orange, when complete orange, look at orange as your server. So look at that little strand of that orange as a virtualization, assuming that you have already installed an hypervisor in that orange. So when you open orange, you're going to see different shares, right? So when you pick one part of that orange, it's an instance of that orange. You understand? It's a portion. But you don't forget that instance, the orange act as if even when you pull one instance, everything you see in the same orange, that's what you're also going to see in that stuff, right? I don't know if you understand what I'm trying to say. So an instance is a portion of a virtualized VM. Do you understand now? Where is my... So this is a server. This I put an hypervisor on it. Maybe I put an hypervisor enable me to share this server and make use each of this part of this server as if they are independent, right? This part of this server that I share is called an instance of this server. You understand now? So please note that that's an instance. So what we are going to do now, I will not recommend you use a server in your AWS to do this. You can use this is one of the reasons why I said we should use a Linux in our training because of this. So we are going to install Docker in our VM. I'm going to share the link with you. It's simple. You can do a simple installation like Docker install sudo apt install Docker. It will install Docker for you, but it's not the best practice to do so. Now, let me go into another aspect of the Docker. Just like the way we have Git, right? We also have a Docker hub. A Docker hub is a public VM that have already been created for anybody to use. All you just need to do is just to come here and sign up, just the way you sign up for Git. So any Docker you build locally, you can also save it here. So if time will not permit, I won't want to cloud your stuff with so many things. I would have said, okay. Do you know another interesting thing about Docker? By the time you do an image, you run an application. Let me tell you another advantage of Docker, why people also use Docker. You see this image, immediately I run it. Now, I mean, what is there any image running now? Okay, no one is running now. Assuming I run this one. Okay, now this one is running. If this one is running and is showing, is working, I can zip it the way it's running like this. You know, it's already running, right? I can save a running instance, a running container. Just the way this one is running. You know, maybe it was an image, right? I start the image now, it's running. I can decide to, excuse me. But what I just did now, I've entered inside the Docker. Okay, this is not what I actually wanted to do. This is what I wanted to do. Let me come out. Control C. Let me close Control Z. Let me close this. I'm already inside the application now. I don't want to go inside the application. Let's come here. Let's say, for example, I want to list the Docker that I have in my system. I'll say Docker image list all. Yes. So this is the image. Remember, this was the image that you saw just now, right? In the GUI. This is the CLI. Clear. So I say Docker PS to list the ones that are running. These are the two images that is running. Docker PS. So the same way, these are the Docker image that is running. This one is running at my port 80. This one is running at port. This one is running at, these ones are running locally. Don't worry, I don't want to should we go a little further? Should we dive deep? Can we assimilate if we go a little further?
Okay.
So I don't want it to look so heavy. Or should we push the playground to tomorrow? But know that tomorrow I want to spend time enjoying this thing.
Yes, please, let's push it to tomorrow. Let's understand this one.
Okay. So I'm going to send you a video to watch. And that one we build more of the knowledge base. You know what we just did there is granular explanation of the Docker, right? so that everybody can understand it. You understand? Now, the advantage of what I just did now, there's nothing about Docker that we'll talk about that they will mention to you that you will not know what they're talking, because the foundation is well laid. But you need to build a little ahead of it so that when by the time we start practicing tomorrow, we will not answer so many questions than expected. You understand? And with the look of things, we are going to have a class on Wednesday because we need to match up the gap. We need to close the gap. We still need one more. We need like 3 extra class. So, but let's start with Wednesday first. Is that okay?
Okay.
So I'm going to communicate with us. Let's have the class on Wednesday. So we have tomorrow, Wednesday.
Patrick,
I can hear you.
Patrick, please, can we pick any other day except Wednesday?
Okay, which other?
I travel on Wednesdays. I'll be too tired.
Okay, we'll take the conversation to the group. We'll organize and agree on a good day. Or you can drop your most favorite day in that group.
Any other day except Wednesday.
Okay, so that we can have it Tuesday. Let's have it Thursday.
No, Tuesday will be okay.
Tuesday is okay, right?
Yes, Tuesday is
okay,
good.
all of us.
Tuesday, what time?
Same time.
Okay.
But I know some of us-
Tuesday is okay.
Tuesday is okay. Okay.
Anything earlier than 9 o'clock, I will not be available. It's not okay for me.
So Tuesday 9. Tuesday, please. I'm going to share you are still going to use the same link, but I want us to be ready Tuesday because we are going to dive deeper. So that by the time we finish it Tuesday, then on Wednesday, on next week, Saturday and Sunday, we enter Kubernetes. That we'll still have like 2 weeks to play with our Jenkins and other Terraform, other stuff, you understand? Just walk around that. Then I'll know that you are ready. Then what will be remaining, I will still tell you other things, prepare you also how to get job, then push some materials to you that will make you solid. You understand me? You understand? There was a time I wanted to push this beginners. It's not like really beginners, this onboarding into DevOps to people. But I realized that it requires experience to lecture this class. So that's why I'm personally taking this. And I think I'm going to continue to take it. But please, I need the way I love the way you put your energy in the last module. Let this energy be more. Don't confuse, don't be afraid. We are already doing it. Yeah. So the same way, just like the way you do on that Docker application, the same way you also query Docker. When you say Docker automatically triggers. If I say Docker version, it triggers the version that I have. If I say Docker image or Docker container, if I say Docker container, list all to tell me all the Docker container list, ls. The same way, list al, it will list all the Docker, Docker. If I say only ls, to list ls, you understand? If I say al, thing's supposed to give me only the one that is running, the latest, something like that. So these are the things we're going to be talking about in our next class, how to build an application and how to run it as a Docker. So it's simple. All these syntax are ready everywhere. So what am I trying to say is that I can zip an image into a Docker, but by the time I start the image, it starts running. That image that is running, I can save the image that is running. That's one of the advantages of a Docker. Because before now, the developers will develop an application, Before now, the developer will develop an application and push the code to develop to the operation team. The operation team will now deploy the code and run it. Sometimes, maybe the operation team does not understand how the application was designed. They will not tell the developers that they did not do the good work, that the developers did not develop well. Well, the developers have tested on the application, on their server, it's working. The developer will say it's working. The operation team will say it's not working. So this will be the bridge between the dev and the operation. Now, with the help of a Docker, when the developers finish developing and push it, as the application that is running and save the application that is running, because it's already running, you understand? So the operational team will just carry the application that is already running and put it in the server. So there is no need of the operation team saying the application is all running. Just a minute, please. So there's no how. The operation team will not tell the developers that say that the application did not work. Because why? The developers have developed it, they have zipped it, they have run the container, the application is running, they save the application that is running, they save it. That process of saving an application that is running is called artifactory. Artifact. So now a running application is called an artifact, meaning it's tested, it's running. It's no longer a code now, it's a Docker running container. So you can save that artifact in a Docker hub. So when you go to Docker Hub, most times what you see there are artifacts, our application that is already running. You understand? So you just zip it in a server and just start it and it's running. So that is one of the advantages of DevOps. This is one of the reasons why DevOps actually starts, the work of a DevOps engineer actually starts from Docker. But though now is going a little higher because they expect a DevOps engineer to understand coding too now, so that you can be able to support the developers very well. But not like you building code, but you should understand the framework. So that is it. So this is just the basic things that we are going to be learning. Come tomorrow and practicing come tomorrow. I think for now I can stop this class and create more room for questions. And I really enjoyed talking to you guys today. And did you enjoy my lab today?
It's enjoyed and understood.
So yeah, thank you too. So I will share the link to you. You are going to install Docker in your system. So how do you install Docker? I mentioned Docker is owned by this Docker company. So you come here and also run your Docker. Just say, let me just get the link. I'll share you Docker installation on Ubuntu, since all of us are using Ubuntu. You see, docs.docker.com. So this is the right site to go. This one is DigitalOcean. This is a separate company. This is the owner of the Docker company, docker.com. So when you click here, you see the process. Just the way we installed LAMP application. That same way you also install it. So I'm going to share this link for you. See the reason why we did that LAMP application first, because we know that we need it. So since everybody is using Ubuntu, you can use this. For use that anybody using Mac, you can also come here and click Mac. So let me share it in our group. So today, before or tomorrow, or some of us that are using different time zone, install this Docker in your server, in your machine. Okay, I think I can. Any other question? Any question?
Yeah, Patrick.
Go ahead.
I know I've sent a Docker image to Docker Hub. I created a Docker Hub account. So what is the interrelationship?
You have set
up a Docker Hub account. Yes, and I transferred one of my image to the Docker Hub account.
Okay, a Docker Hub is a public, let me say it's an application it's an infrastructure that is already been set up for anybody to use, just like the way Git is. Remember, we have Git. Git is supposed to be running your local system, right? You can have as I mentioned, that you can have a general bank where you go and create an account and save your Git or your code base in them, right? That's called GitHub, right? So Docker is also an application that you can run in your local file. But you can also create an account, a storage account, where you also put your Docker application and save it there. So you can either have a public and also have a private. You understand? If you want people to contribute to it, you can also have an open source. So every public cloud has their own Docker management repository or artifactory. So it's not in AWS, it's called ECRO, Elastic Container Registry. Yeah, it's used to manage Docker application, especially a running application. That's what ECRO is used. While in Google Cloud, it's called GKRO, GCRO. That's Google Container Registry, and other applications also have it. Also have their own, but all of them uses the same Docker language. Are you saying that Docker is the only application used to containerize? No, Docker is not the only application. That will be a discussion for another day. The other application that you can also use to containerize, but Docker is the mostly used. You can also do research on that. Any other question? Hope I answered that question. Hope I answer you clearly.
Yes, Patrick.
Any other question, please? Okay.
So from the explanation, what do you call it? Sorry, I missed my line of thought.
Let me just rephrase. Maybe during that process, you can remember. A server, you put an hypervisor. An hypervisor enable you to virtualize the server by enabling the user to take a portion from that server and use it as if it's using the whole server, right? That process of dividing that server so that they can be using the resources separately, independently, is called virtualization. That a part of the server that is collected is called an instance. But after you run an instance, you are going to also install an OS on it. Then after installing an OS, you start putting an application. One of the applications that can also run is a Docker application. The Docker application enables you to manage all the dependency of other applications so that you don't need to be bringing, other applications don't need to be bringing their dependency. With that Docker application, all you just need to do is just pick the image, just to bring the image of this application you want to run on this your VM, and they will be running independently. You can decide to link your Docker container to be communicating within themselves. For example, if I have a database, for example, now remember we did LAMP last time, Linux, Apache, PHP, and MariaDB. So in this case, you're going to have Linux, which is the server, which is the Docker engine. So you're going to be having Apache container, PHP container, MariaDB container, but they will be communicating within themselves using the port. You understand? So you can have 5 PHP and 1 MariaDB. You can have, you understand? You can have so many parts of that WordPress application running in one MariaDB or several MariaDB run attaching to different themselves. So just like that, you can have a complete stack of different applications running. Now, I'm going to talk about the difference between a pod and a container. A pod is basically used for Kubernetes engine. But I'll tell you the difference between a pod and a container in our next class, which is tomorrow. So let's focus on this Docker. So that being said, I think I can round up my class today. I just did a summary of what it's all about today. So that is it. So thank you so much for the time. And I remain again Osato Hame, Patrick Aigbogun. Tomorrow is hands-on. Tomorrow is our what? We'll call tomorrow our playground. please come with your laptop. Today, you are still going to do some playground, which is installation, which I just shared with you. Install it and do, but tomorrow is playground. So no talk, it's more of practice. It's just because we are introducing a course today. That is why I spent time in explaining and giving a graphic explanation. So I'll see you tomorrow. Tomorrow, come in time so we can cover more ground. Thank you so much.
Thank you very much and good night.
Yeah, bye. And I think we have, sorry, before we go, we have somebody that came to spy. Let me see if she's still here. Yes, her name is, please introduce yourself again.
Good evening, everyone. My name is Yes, so I just said everything is fine.
Wow, sorry, we didn't hear you. The audio was not loud.
Oh, really?
Yes,
Okay. Okay, can you hear me now?
it's kind of coming in, going out. Can you come close to the mic so that?
Okay. What is my earpod?
Ah, okay. I think your audio is not really friendly tonight. Maybe network.
Hello.
Yes. Can you
Hello,
continue like that? Continue that pace. Yes.
Okay. So like I said my name is to I've been looking.
Oh, okay. Don't worry. Don't worry. Don't worry. I think network is not interested. It's not giving you us audio today. Her name is Rasonel. She is part of February session. This February session. She just wants to come and see, just spy and see how the class is going. So I told her that we hardly do this, but she just insisted. I said, okay, let's just give her opportunity to come and see the whole lab is. You understand? And I know you hope you enjoyed yourself. If you can just raise up your hand.
Yes, I did.
Okay.
I did.
Okay. So that is it. So thank you so much. Thank you, everybody. I'll see you. See you when I see you tomorrow. Bye.
Bye.
Yes.
Bye.
Bye.